things. In this video, we'll go over the elementary particles called quarks, of which, for example, proton and neutron are basically made up. And quarks, they are very elementary. In theoretical physics, it's taken that there's no smaller particle that they can be seen as built up from. So they are these elementary particles. And first of all, I will present the 6 quarks and talk about their organization into 3 pairs, from the lightest to the heaviest. So, namely, we have up and down quark being the 2 lightest ones. The middle ones are then strange, charm, and there will be notation I will mention in a second. And then for the third row, we have bottom and top. So these 3 rows consist of together 6 different quarks. Each has its own name, and also more commonly these are not written with the full word. This is a name for it, but the point is usually the first letter is chosen as the mark for it. So up, charm, and top will be denoted as U, C, and T. And the same goes for these on the right. So what we have left is these beginning letters. They all have different individual letters as the first letter. And so we have U, C, T, D as B, up, down, charm, strange, top, bottom, the 6 quarks. And already this table, not only did they divide it into from the lightest to the middle to the heaviest, but also it got actually divided on the basis of charge. We have something called charge of these particles, and in a second I will present something called hadrons. And hadrons are basically particles made out of these quarks. So proton and neutron are examples of hadrons made up of 3 quarks. So a charge of up, charm, and top quarks is 2/3 E, and then the charge of down, strange, and bottom quarks is -1/3. Now, I will give the example of 2 hadrons, as I mentioned. Hadrons, as I said, are basically particles made up from 3 quarks. An example of them is proton and neutron. So let's talk about proton and neutron. Proton is composed of 3 quarks. Now the question is what 3 quarks, and I will tell you. The 3 quarks that a proton is consisting of is UUD, which means UUD, I can write it like this. And now if I want to look at its charge, I can use the charge that U and D have. So we have U has 2/3, then another U, I add it together, then plus minus 1/3. So together it's 1. And so this matches the knowledge that proton has plus 1 charge. So this is for proton. And then for neutron, basically the composition is similar, also just up and down are used again, up and down quarks, but they are used in a different combination. So we have U, D, D, we have 1 U and 2 D's in this case. And what it will give is 2/3 minus 1 plus 1D, which is -1/3, because D, just like S and D, will all have -1/3 charge, and then another D. And this together gives 0, which is the charge of neutron. Neutron has neutral charge 0, proton has positive charge 1. So basically, to just sum all of this up, in this video we've covered the names of quarks. And there's these 6 quarks, up, down, charm, strange, top, bottom. And they can be organized from the lightest to the heaviest. Also, the notation is in the way that we use the first letter of that word. Then, up, charm, and top have charge 2/3, and down, strange, and bottom have charge -1/3. And I gave an example of hadron. Example of the hadron is proton. That proton will have 1U, 1U, and 1D. That together gives charge 1, which is as expected. Just like with neutron, the combination is slightly different. UDD, which is 2/3 minus two first giving zero charge, which is also expected.